Today we solve numericals. Okay. First we cleared the concept. First two classes we cleared the concept what is work and what is variable work. One thing missing in previous lecture, missing here, that graphical problem. Okay. That's the graph represent of work. Okay. If confusion here some student asks, so if that is a position. Okay, there is a position, initial position x equal to 0. Here some final position x equal to x final. So that is a displacement and there is a constant force. Okay, so that is work done. Okay, in case if a area represent a work done. Okay, if force is variable or force is constant. Okay, that's important. If force is variable or force is constant, here the force is variable. Okay, the from position a point here, the displacement here to there, and the variable forces. There's a typical or some differentiation. There's some calculus part in me here, but we ignore the calculus part because okay, that's the class 11, 12 complicated maths, but not discuss here. We discuss only the area represent work done. If force is variable or force is constant. Okay. Now we solve a numerical. A basic sum numerical. We cannot solve all numerical here. Okay. If two bodies are equal masses are placed at height h and to h, what is the gravitation ratio? That is very easy. If mgh, that is also mass gravitation potential ratio. Okay, equal body, equal masses at height h and to h. What is their gravitational potential energy? So some h as mg2h. Both are same. If energy u1, that is energy e2. So that is equal to mgh times 2. So that is a e1, that is e1, that is e2 times 2. So if cross multiply here, we get e1 by e2. We get a 1 ratio 2. That is e1 ratio. That is a ratio of their gravitation potential. Very easy. Okay. One key point to hit this, just keep on notes down. If some numerical given a kgf, if there's a kgf. What is kgf? If suppose 150 kgf, now we convert into Newton. Okay. If convert into Newton, we multiply it by 10. Okay. Suppose 10. So get a Newton. Okay. So multiplied by 10, we get a Newton. Suppose that is 15 Newton. Gravitational potential energy stored in these. Find the height of the box above the ground. Easy problem. Suppose box weight these. Okay. So that is energy, that is 1 for potential energy 700 joule, and that is mgh, that is it is mgh. What is g? G is the gravitational acceleration, is 9.8. So here multiplied by 9.8. If 9.8 is given, then we calculate the 9.8, otherwise you always use 10. So here m is g is a Newton. So 150 into 9.8 into h, we get 14700 joule. So here the h equal to 14700 divided by 150 times 9.8, cancel this is a 0, cancel 2 0. So here multiply 49, 40 and 2 the 98, and here that is a 300. So 15, 20 to 10. So H equal to 10 meter. That is question number 3. Okay. So kgf is represent the mass. That's important. What is the kgf is represent mass. Okay. Now very easy concept here. If suppose calculate if suppose number 6, a boy weight 25 kgf climbs on the first floor of a height 3 meter above the ground to a third floor to height 9 meter above the ground. What will be the increase the gravitational potential energy? Very easy question. What is the increase? So mg capital H minus final bigger capital H. If that is a 9 meter and a 3 meter, so that is a question number 6. So mass is 25, g 10, 25 times 10, and H is 9 minus 3. 25 in times 10, that times 6. 25 times 6 is 150, and that is 10. This is very easy numerical. Okay. Now, if I calculate the diagram numerical problems, okay, like number 9. A block A, weight of 100 Newton, that is downward act, pulls at a slope of length 5 meter, a constant force in 100 Newton. Okay. What is the work done by the force if block A 5 meter of the road? What is the work done by the force? Very easy. If a force is 100 Newton and displace is 5 meters, so very easy get the answer. That is work done equal to force time displacement. That is displacement is 5. So is 5, that is equal to 500 joules. Next, on the slope. What is the increased potential energy of block A? Okay, increased potential energy. What is the potential energy here? What is the potential energy here? Okay. So number 2, increased potential energy means we can calculate increased potential energy means suppose here the potential energy is height is 0, so that is 0 potential energy. If box goes here, so h is 0 and here h is equal to 3. So mg capital H minus small h is equal to 0, capital H equal to 3. So mg, the weight is given, the weight is 100 Newton, box weight. So 100 Newton, 3 minus 0, so that's the 300 joule, very easy. Okay, and final point number C. Amount of difference work done by the force, by increasing the potential energy of the block. Okay, so difference, what is the difference? Very easy. The difference is given, that is 500 joule minus 300 joule. We get a difference is 200 joule. That is amount of difference work done by the force increasing the potential energy of the block. So if the energy that is 500, first we calculate the slow 500, and here the potential energy is 300. So here the potential energy finally the convert is 500 minus 300 difference, that is a 200 joule. Okay. So the difference 200 joule energy used to doing a work against the force of friction between the block and slope, which appear as a heat energy as a concept. Okay. Now we discuss another question here, the ratio. Suppose question number 13. Two body have their masses ratio 5:1. Kinetic energy this and this. Calculate their velocity. Very important. 13. kinetic energy that is equal to half mv square ratio half mv square half mass 5 ratio 1. Suppose take a 5x. Velocity 125 y square. 5 velocity, sorry, not velocity square. Okay, sorry. Find their velocity square. Okay, sorry. Find their velocity square, that is a v square. V1 square, that is a v2 square. So that is also half a, that is 1x times v2 square. So their ratio is 125 ratio 9. So we get cancel x cancel 2 cancel. So 5 v square v1 square by v2 square we get 125. So cancel these, we get 25. Now v1 by v2 square root of 25 by 9 we get 5 ratio 3. Very easy numerical. Suppose here we choose the question number 16. A cannonball of mass 500 gram with a speed of 5 meter per second. The kinetic energy and its momentum. Very easy question. So kinetic energy, that is, we know that that is equal to half mv square. So half mass is given 500 gram. Now convert into kg, 1000, and v is 15 meter per second square. 15 square. So we get half, that is 2, 1 by 2, 225. So 225 divided by 4, we get 56.25 joule. Very easy. And what is the momentum? So similarly, momentum is P equal to mass times velocity. Mass is given 500 by 1000, converting kg. Velocity is 15, 52 to 7.5. So 7.5 kg meter per second. Now suppose there is an important question number 20. How much work is needed to done when a mass of 50 gram to give a momentum 5 kg by meter per second square? How much work? If its mass is 50 gram, momentum is this. So we know that energy, how much work? Work also energy, that is the velocity, that is a half mv square. So lack of space, we will calculate here. Okay, so number 20, from here, number 20 is mass equal to 50 gram and momentum equal to 5 kg meter per second. So what is the energy? That is equal to half m v square, half m mass 50. If I solve this, if mv times v, half mv, that is p momentum, and what is the v? 50 by gram, 1000. Okay, so not velocity. Okay, if that is not a velocity, suppose a mass. What is the velocity? Velocity also p equal to mv, p by m, p by m. So now we solve this. That is half times 5, p times 5, and what is the m? 50 gram. Convert to kg, SI, 1000. 0.055 5 by 2 into 100. That is 5 to 2.5. 2.5 into 100, we get 250 joule. Okay, as a result, we get a result is 250 joule. Very easy. Okay, simple. Now the question number, suppose 22. A bullet of mass 50 gram moving with a velocity 500 meter per second penetrates 10 centimeter steel target and comes to rest. What is the kinetic energy possessed by the bullet? Very easy. Okay, if initial velocity this and final velocity u equal to 500 meter per second and v equal to 0, and the displacement is 10 centimeter, means 10 by 100 meter means 0.1 meter. Okay, and what is the kinetic energy possessed by the bullet? So kinetic energy means half mv square. Half mv 500. Similarly, if energy is half m means 50 over 1000. Velocity means 500 into 500, and 0 0 cancel. 2 0 here also cancel. So that is 2.5. 5 5 is 25. 25 2.5 is uh, 62.5 times double zero, and we get 6250 joule. Okay, very easy. What is the average retarding force of the target? From Newton third, you know that is equal force, retarding force. Both are same. That is one. I said joules. Now what is the force? That is a joule. Now convert to the force. So very easy. So work done equal to force into displacement. So here force equal to work done over W. W over D. 0 joule. At displacement we get a 0.1 meter. 0.1 convert double zero. Sorry, that's a Newton. Okay, 62500 Newton. Okay, now the last question. 23. Spring in a keep compressed in a small trolley of mass of 0.5 kg laying on a smooth horizontal surface shown in the figure. When a trolley is released, the founder move at a speed of v 2 meter per second. What is the potential energy of the spring possessed by the compressed? 0.5 kg laying on the smooth horizontal surface, that is a v. So very easy. So that is the potential energy. Convert into kinetic energy, both energy systems. So how m 0.5 v square means 2 square. Okay, so we get 2 to cancel, 0.5 by 0.5, so 2 into 4. If this is by 0, 5 2s are 10. 2 2 cancel 1 2. That's it, get the answer. Okay, this is a basic numericals. Okay, if any doubt in numericals, if you solve, first you can solve all the numericals. Okay, if any doubt in any numerical, put in comment section. Okay, I will try to give the answer. Very easy numerical, basic formulas here. Okay, concentrate on calculation, basic idea know about the formula and solve it. First read the question and clarify what formula you can use and solve it. Okay, very easy. And okay, end of class here, and meet the next class. We discuss the energy and work relation. Okay, thank you.